All right, welcome everybody to another episode of TGI Kubernetes. It is Friday, 1 p.m. here I'm not in Seattle anymore, I'm actually in Bellevue. And on the west coast of the US. And we're going to be talking some Kubernetes. I'm actually in my new office here. I'll give you a little bit of a tour. But first of all, some hellos to some folks on the line. So we have Martin from the Netherlands. Lamati, good to see you. It's been a long time. Suresh from Hamburg. Abdullah from Bangladesh. Shahar, good to see you. Yeah, thought leaders. Yeah, so those who didn't see it, I posted this thread on sort of how to thought leader on Twitter. It was very tongue-in-cheek. Nima, Alan from Scotland. Ivan, good to see y'all. All right, so I've moved offices. So Heptio was in Seattle, and now we've moved. Ivan from Colombia, good to see you. Ivan, maybe there's a. Yeah, so I moved offices. We were in Seattle, which is closer to the ocean, to the Puget Sound. I'm now in Bellevue, which is like kind of a suburb that's across Lake Washington. That's where the VMware offices are. We no longer have independent Heptio offices. It's kind of a little bit sad, but it's also, the price of progress. But I do have a view, so you can check out my cool view. So we have we got buildings and stuff, and so it's kind of cool. But because I have the window, I have a little bit more road noise and stuff. The studio that we'd set up in Seattle was a little bit of a closet. So Frederico, good to see you from Gothenburg. And Timmy, good to see you also. All right, well, welcome everybody. I'm really excited to be doing TGIK again. I'm going to be doing more of these, trying to defend my schedule and keep the time because I really enjoy it. Let's see, let me adjust my camera a little bit here. For those who don't know, I'll give a little intro here. TGIK is a weekly live stream that I do where review some of the stuff that's happening across the Kubernetes ecosystem and the cloud native ecosystem, and then do a deep dive on a technology. Oftentimes, it's a technology that I don't have a lot of personal experience with, and so it's kind of fun to explore these things together and see what we can do. One of the things, that I did want to note is that we have a new channel. Part of sort of integrating Heptio into VMware is that we have transitioned the Heptio channel to the VMware Cloud Native Applications channel. It just rolls off the tongue, doesn't it? But just trying to collect a lot of the sort of stuff that we're doing, including TGIK, including a bunch of other stuff across the way. So that's a lot of fun doing that. And so the topic that we're going to be covering today is this tool set for wrangling YAML. So yet another sort of configuration templating tool set. This one is really interesting. I did a TGIK live at KubeCon in Barcelona on this, where we explored it. A lot to like that I'm really interested in getting into. The tool set itself is K14S, which is Kubernetes tools. But the ones that we're going to be looking at, or at least I'm going to be digging into today, is YTT and Kapp. But we'll get to that. But first of all, sort of some notes here. So the first thing, let me switch to my screen. So the first thing that I want to talk about is that we have a HackMD that you can all start putting some notes into. So if there's something interesting, or if somebody wants to say, hey, this is the time when Joe started talking about X, there's a good place to put that. And so here's all the stuff that I'm going to be going over here real quick. So the first thing is the image for this particular episode was here. This is the element Yttrium. And I'd like to say that I knew how to pronounce Yttrium, but I actually had to ask Google how to pronounce it, and it actually told me. But it's an element that starts with YTT, and so I knew that this was an element. I know nothing about it, but when I saw the name of the project, YTT, which I think is YAML templating something or another, then I immediately thought of this, and so that was kind of fun. And so we'll learn a little science here together. Kind of cool. It's a really cool looking crystal though. And then, yeah, so that's the first thing. Now the next thing is George is not going to be manning the chat today because he's actually doing a lot of work getting ready for the Kubernetes 1.16 release. His job is to pull together a lot of the release notes in the blog post, and so he's helping out there. But I asked him, I'm like, hey, what are the big things coming in 1.16? He put together a really quick summary for me. The first thing is a lot of the work going in is around extensibility via API machinery. Most of the feature caps this time around were around that. Stability production features in kubeadmin, things like HI, that type of thing. Really interesting to see us continue to drive forward with SIG cluster lifecycle. There's some scuttlebutt right now around sort of do we want to move kubeadmin out of tree and maybe get rid of cluster and stuff like that. 1.15, right? I'm sorry, we're not peering that far into the future. Thanks, Suresh. And then right, 1.15. I'm not like crazy. Is this the 3 days ago? Yeah, so this is actively being updated right now. Okay, like time flies, but not that fast, right? Let's see, other stuff. There's some storage work going on around cloning and snapshots. Go modules, finally moving to that for Kubernetes. That's one of the things that helping to sort of push stuff out of tree, really prune dependencies. And then there's just ongoing work again to move cloud providers and the storage implementations out of tree. So really taking a lot of the extensibility mechanisms and taking stuff that was built in and moving those to use those extensibility mechanisms. And so it's really great to see that stuff continue to happen. So yeah, some quick hellos. So Dimitri, good to see you. Thanks for joining us. Dimitri is one of the authors on the project we're going to be covering. And then Walid, good to see you also. And then Suresh, you were reminding me. And then Marco from Milan. Nice to see you, Marco. Let's see, did Ethereum get its name from the elements as well? I don't know. I mean, but it's not uncommon. Whenever you're searching for names of like open source projects, it's almost impossible to find a name that's interesting and hasn't already been taken. So it's not uncommon to see folks like borrow element names for this. I know that there was a virtualization project that we were doing at Google called Vanadium back in the day. So a lot of stuff doing that. Okay, more notes. So this is something that's interesting. Google, and I got an email because I have a GKE cluster that I launch. Is moving away from their service catalog interface. They're actually deprecating that, and they're moving everything to this thing called the GCP config. Wait, no. Is this the thing that I was thinking about? No, this was not the thing I was thinking about. Shoot, where did I get this link? I don't even know what link this is. This is a thing that I hadn't seen before. Wow, I am like, not the config connector. So we're going to find the right link. GCP service catalog, right? So anyway, so the service catalog was is a way to essentially, yeah, so this is the GCP, so the service broker was essentially a sort of super generic way to get access to services. But I think what we're seeing is folks are moving towards something that is a little bit more, I didn't think this was the one that we were talking about. Maybe, is this, okay, but is a little bit more sort of native to Google, to Kubernetes, where instead of, gosh, give me 3 seconds here because I'm trying to find this. I had a link to the thing that I was thinking about, and this isn't it. But the service catalog then is a very narrow sort of like API. It's friendly for non-Kubernetes systems because it's a relatively simple API. But we're finding a lot of folks are moving towards things that are more Kubernetes native. So that instead of having, say, hey, a very narrow API that says give me a MySQL database, people are moving towards representing these things as CRDs with having controllers, which lets you have a lot more richness with how you actually specify configuring and managing external services. And we saw Amazon do something similar, where, like, hey, if you want to create an RDS instance, create a CRD. That then goes ahead and causes that RDS instance to be created. I guess this is the one. The config connector is the one that I was thinking about. But yeah, so this is, there's not a lot in this repo. That's the thing that confuses me a little bit. I think maybe it's all closed source, perhaps. I don't know. So, but anyways, I think it's really interesting to sort of see how some ideas are tried out using the extensibility mechanisms in Kubernetes, but over time, folks figure out what works, what doesn't work, and we'll see evolution of things from like using a service catalog to something that's much more Kubernetes native, which is really interesting. All right, so next topic, Tigera and Calico is starting to actually adopt eBPF, so this is really interesting. I am not an eBPF expert. It's one of those things where it's on my list where I'd really love to be able to actually dig into it at some point. But essentially what it is it's a programming language that can get compiled down into a relatively generic machine thing and get installed into the kernel and run in the kernel. So it stands for Berkeley Packet Filters. But to some degree, this feels a little bit like sort of, pixel shaders for the network, right? Where you have this, and this is my impression, and I haven't done a lot with it, but it's this idea that you have like sort of a specialized language, you can compile that down. I don't think there's a specialized language necessary. I think you can actually use a bunch of languages. And then it gets run in a sandbox mode inside of the kernel for being able to do stuff. And so this, essentially is a way to extend what you're doing with networking stuff without creating more and more complex systems like IP tables. Kind of cool stuff. All right, let's see, more notes. The Certified Kubernetes Administrator certification is now valid for 3 years. So this is very exciting for those who took this exam. They get to kick that can down the road again, which is really good. These things can be pretty challenging, and so it's great not to have to stress out about it all the time. Let's see, Bogdan from Romania, good to see you. And Christoph, you found us, awesome. All right, and then one of the things I wanted to talk about here, and so this is the first time I've done a TGIK since KubeCon, and one of the interesting announcements out of KubeCon was this thing called SMI, and I don't know if this is something I could do a TGIK on because it's a specification, and we're still very early in terms of. Yeah, so Bogdan is saying that Cilium, which we also did at TGIK, I think it was Chris that did that, also use eBPF extensively, so really interesting. Orhan, good to see you from Turkey, from Istanbul. All right, so SMI is really a sort of an interface. In some ways, you can think about it as taking the ideas for ingress, which is like, hey, we're going to have a standard sort of way for describing stuff that can work across multiple ingress controllers. Can we apply those to service mesh? Still very, very early. The interesting thing for me is it's actually broken out across 3 different types of things that you can implement. And when I first started looking at Istio, at service meshes, my approach was like, hey, there's 3 reasons why folks are interested in service meshes. One of these is sort of security and policy, being able to do encryption between everything, maybe have some sort of generic, centrally deployed access management between services, that type of thing. A big thing is telemetry and observability, what's happening with my services. That's one of the other huge features out of a service mesh. And the other one is sort of traffic routing and management, being able to do blue-green, redirect, that type of thing. The interesting thing for me that I really like about SMI is it actually starts to decouple those different features, right? So like, hey, if I just want traffic management, there's a spec for that can be separated from the encryption. Still very, very early days for this, but I think this is a really interesting evolution of the service mesh space as we're moving from sort of something like Istio, which, obviously a system that a lot of people are excited about, but has a lot of trade-offs like any system, right? There's trade-offs that are made to moving towards like, can we actually have multiple implementations, multiple ideas, a thriving ecosystem of ideas behind service mesh, and have those things actually have room to be explored, that type of thing. Yeah, so Bogdan's like CRI or CNI, but for service meshes, which is really interesting. Um, Let's see. So I'll get to that question well in a second here. One other thing that I think is super interesting. So this was a talk at Cube. I haven't watched the talk yet, but I talked to one of my friends on the Knative team, and so this was a talk by Matt Moore and Ville. And it's fascinating because as Knative has developed, they've taken sort of the Kubernetes object model pattern, sort of the idea of kind and versioning and spec and status and the metadata. And they've gone through and they've extended that and added some new capabilities. And the interesting thing here, and if you look at the title here, it's called What the Duck. I think Ville really wanted to call it this, I'm guessing, and they probably had to tone it down. But the idea here is that we can take a certain amount of duck typing and apply it to Kubernetes resources. And so here we have duck typing, whereas that if a part of the YAML fits a certain type of schema, you can operate against that without actually knowing the rest of the YAML. And so if you have this idea of like, well, this resource has a pod template, right? But it could be a replica set, it could be a deployment, it could be a cron job. Those are all things that actually somewhere in there actually have something that is the pod template. Well, we can now operate against that in a generic manner using sort of duck typing ideas here. Duck typing is that if it looks like a duck and quacks like a duck, then treat it like a duck. That's kind of the idea behind duck typing. And then they further extended this by taking some other patterns that are really useful, like, hey, every status should have an array of conditions. We do have that in a couple places in the Kubernetes APIs, but the idea with this is that we can really sort of make that be a regular thing so that conditions are everywhere. And universally, like, a condition being true is a bad thing. So if you see something with true, you show red, you show a warning, whereas condition being false. So like making sure that the sense of that condition is uniform, and then having something like configured or completed. I'm trying to remember the a standard condition that means that, hey, this thing has converged. So some really interesting ideas coming out of a lot of the work in Knative, and it's going to be interesting to see if we can apply those to other places in the Kubernetes ecosystem. And so this is the presentation, and there's the video here. Yeah, and there's Ville and there's Matt. Obviously they're playing with the duck typing thing a lot. Okay, so Walid is like, what do I think about Solomon's hike tweak? If WasmWasm existed in 2008, we wouldn't have needed to create a Docker. That's how important it is. WebAssembly on the server is the future of computing. I think that's hyperbole. I think right now this is very similar to unikernels. I think a big part of the power here is not just how do we actually compile and execute things, what the runtime looks like, but the environment around these things. And I think the thing that made containers so successful was that you could essentially take a stock Linux, a stock sort of Linux distribution. You could take those install instructions, put those in a Docker file, and actually make them successful and actually get something up and running. That's very different than saying, hey, I have a new compile target, a new architecture that I can talk to. There was, we have technologies like gvisor, we have unikernels, we have, oh God, I'm trying to remember. There was the sort of the x86 assembly analysis that got built into browsers also, which was a similar type of system. How can we take x86, sanitize it, know that it's safe to run, and then go ahead and run it? That's essentially sort of hits the same level as WebAssembly. I think those things are all great, but it's not a replacement of actually having a sort of standard tool chain, a standard set of libraries that's very easy to actually get to. So yeah. So I think it's an interesting technology. We'll see where it goes, but I don't think it's necessary at the same level of containers, and I don't agree with Solomon's comment there. Yeah, and then Lamati says, if you spent time using dtrace, BPF trace is a dtrace-like interface on top of eBPF. Super useful. So very cool. So Brennan Gregg has some killer posts on that. Yeah, Lamati, if you want to put some details under that item in the HackMD, that'd be great. All right, so that is a lot of stuff that I covered. Sorry that it took so long. But yeah, all right. So you all are adding newts to the HackMD. Very cool. All right. So I want to start talking about Kubernetes tools, K14s. This is a blog. Oh wait, there's a blog post here that I Where to go? Where to go? The blog post. Oh yeah, and then there's another blog post that goes into YTT directly. But this blog post, this is the one that I'm actually going to go work through a little bit. And I started looking at it, but I actually haven't had a chance to go through this yet. So this should be fun. We're going to go through this together. And this is actually an old idea. When we first started Kubernetes, we knew that we needed a flexible tool chain on top of all the YAML. And early on, Brian Grant actually started playing around with this, creating a bunch of small programs that you could then pipe together to essentially create a pipeline of essentially YAML muckers that would sort of tweak your YAML, and then you could go ahead and do an apply. And I think, you know, at the time we didn't have enough experience to really do the right thing here. The API patterns were still in flux, and so still very, very early on when that was happening. I also think that he created sort of tools that were probably too small, too targeted. So he would have like a tool that said, like, let me rewrite the, you know, add a label to everything, would be a very separate binary. And so it started looking, especially with Go being static binaries, it started looking like this tool chain would be absolutely ginormous. But I think the same idea, the same spirit is actually carried through with the K14s tools here, in that they are, here's like the other page here, in that it's the idea that you can, you know, essentially take YAML and actually sort of do a pipeline of processing and then get to the point where you apply it, which is a really, really interesting idea. It's applying sort of like Unix philosophy to you know, the Kubernetes, you know, configuration tool chain. Super cool stuff. I'm really, really interested in digging into it. And so the tools that we're going to be looking at specifically here, and there's 4 of them here, and I'm still exploring all of these things. I haven't had as much time as I'd like to really dig into it. But we're going to be exploring YTT, which is essentially a YAML templating engine. And if we go ahead and click through here, you know, we, as in like a lot of the folks watching here, closely associate YAML with Kubernetes. But, you know, it has a long and illustrious history, you know, outside of Kubernetes, and it's used in a bunch of different places. And so Dimitri, who's one of the authors, he's joining us here, works for Pivotal. One of the sort of foundational technologies that Pivotal's heavily invested in is Bosch, which also uses YAML. And so I think perhaps this idea that like templating YAML is a useful thing in a context that goes beyond Kubernetes is a really interesting thing here. I also think that it's interesting that this is in some ways comparable to JSONet, which I think, you know, we've done, you know, I've talked about in the past, but is much more, feels like an annotation extension of YAML versus a rethink of something like that altogether. So this is really the idea with YTT, is it's template in, YAML out. And unlike something like Helm templating, which really operates textually, right? Helm templating, which is really just Go templating, has no idea about the structure of YAML. This actually does operate with the structure. And so I don't believe, and Dimitri can correct me if I'm wrong here, I don't believe it's possible to produce invalid YAML out of this tool chain. Now, it couldn't maybe not apply to the schema of the thing. You may have an invalid schema, but the YAML itself will be parsable out of this. I think there's also opportunities to perhaps, and I don't know if it does this, to actually paper over some of the, and fix some of the common gotchas for things like YAML. So it might be, you know, and you can tell me, Dimitri, because like one of the things, and this is a famous sort of thing, is that people in the past have had YAML where they actually have country code. And then you're like US, UK, ES for Spain, you know, JP for Japan, that type of thing. And that works great until you get to Norway. and Norway is NO. And the way that YAML works is it's not super strict about typing. And so NO actually then says, oh, this is false, right? And so then it stores that thing as a Boolean, not actually as a string, right? And so there's this huge gotcha that like most of the time you don't have to quote strings unless they look like a number, unless they look like a Boolean. And what looks like a number, what looks like a Boolean is not always obvious with YAML. And so I think it's going to be interesting. Like there may be ways that we can do some sort of linting type of things with this in the future, which might be kind of cool. So yeah, so Dimitri's saying that Nima and him briefly discussed how far to go in terms of limiting YAML gotchas at the parsing stage, but haven't decided to do so to maintain compatibilities. I think that's a good thing, but I think like having a warning or a lint or a turn warnings into errors type of thing might be a good way to approach this, because YAML's great until it's not. So we're going to explore YTT, and then the other one we're going to explore is Kapp. Do you all pronounce it Kapp or Kapp? I'm wondering. But Kapp is a Kubernetes supplier. It's essentially, okay, so you pronounce it Kapp. Okay, so it's essentially a better version of kubectl apply. And there's a whole bunch of features here that I find super, super interesting that really go beyond kubectl apply. The big one is that you can actually do a diff versus apply, versus an apply. You can say, hey, I want to apply this YAML. Look at the YAML, look what's in the cluster. Tell me what you're about to do before you do it. That's not something that we actually have in kubectl apply. And it starts to feel a little bit like when you use Terraform as you start doing this. But there's a bunch of other really interesting things here. Like you can actually, with Kapp, you can say only install into this particular namespace. And so, anybody who's watched a lot of TGIKs will know that anytime before I install a system, I do an exhaustive search through the YAML that's about to be applied so that I know what it's doing. Kapp, because it can actually help you understand all this stuff, is a way that you can go ahead and start putting constraints at the tooling level at a place that you trust before you actually go ahead and get to the actual YAML. So that's really, really interesting. And then Bogdan says that coming from a JavaScript, TypeScript background, I still think that Pulumi is the best approach of Kubernetes infrastructure as code. Yeah, I think Pulumi is super interesting also. And I think the power of Pulumi is that it actually goes beyond just Kubernetes. It's a unified thing that looks across a bunch of different infrastructure. I think for me, one of the weaknesses of Pulumi compared to something like this is that to get started, you have to write code. And so if you're a developer, that's great. If you're not a developer, if you come from an operations background, if you don't happen to be a JavaScript, TypeScript type of person, that stuff can be very, very intimidating out the gate. And so I think that stuff like Pulumi is really very much a power tool. Whereas I think one of the lessons that I think we learned from KSonnet is that having something that starts with just plain old YAML and then provides a way to actually add features, add complexity as you need those features, as you need that complexity, is a really important aspect of anything that's actually operating at this layer of our stack. All right, so I've been talking a lot. Let's actually do some stuff. Let's see. So what we're going to do is we have a simple application here. I'm going to go ahead and clone this, and we'll see what we have going on here. CDOs. And I haven't done this yet. So, first we got to install the darn thing. I think I had it installed before. If we go here, there's how to install here. I have. Okay, so the previous version when I installed it, it's like go download it from GitHub. Now we actually have homebrew support on OS 10. So that's cool. I'm gonna remove my old versions here. RM. And then we're going to use homebrew to actually do this. So this is like every time homebrew does something, it's like, let me update myself. Do, 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 do. All right, maybe this will work. Okay, so while we're doing that, let me go through and create a new tab here. And they have a sample application that we're going to work with here called Kate Sample App Example. That cloned very fast. I don't think there's a lot here. So let's see. And the reason that's interesting here is that it does like follow that journey of like, hey, I'm starting simple, just plain old YAML. Let's actually make it more complex as we go. And this might be a way for us to start maybe exploring the tools outside of just YTT and Kapp. So let's see, and then we'll just bring up VS Code here. Yeah, so there we go. We have app, we have a Docker file. Oh man, I haven't pushed a Docker file in forever, so it's gonna be interesting. And then we have a README on how to do this. All right. Let's see, I assume that y'all, let's see, if we look at minimal, there's a container here that's already there. Okay. So I'm going to use that one. We'll skip actually building the, oh, let me do this. We'll skip actually building the Docker container unless we have to. Okay, let's see. So, okay, so we've done that. So Homebrew's done its thing, and now I can do brew install. Okay, so suggestion to you, Dimitri, it's like with packet managers, I know with a lot of them, you can create sort of like a root package that then installs a bunch of sub packages. It might be interesting just to have a sort of K14S package that like gets all of these. And that way, if you add more tools into this tool chain over time, you can actually, you know, people just get it for free. So Christoph's asking, as I am a Pulumi fan, do you think Pulumi looks more intimidating than a wall of YAML to a normal ops person? Yes, and the reason why I'm going to tell you this is that Pulumi does a little bit of abstracting sort of the Kubernetes schemas in YAML, but at the end of the day, you still have to learn that stuff. And so to be effective with Pulumi and Kubernetes, you both have to understand the Kubernetes API and you have to understand how to actually generate that using a program. At some point, we may get to the point where we can actually create high-level, simpler abstractions. But those things come at a cost also because there's always going to be that one parameter that you want to tweak that you can't tweak, and now you have to plumb that through, and that breaks the abstraction. So it's a really hard problem of, can I make something that has a lot of knobs, has a lot of necessary complexity? Can I make that easy? And it really depends on easy for whom. And that ends up being some of the hard part of this. And so I think nobody yet has cracked the code of providing a higher level tool set like Pulumi and hiding the nitty-gritty details of Kubernetes under the covers, at least not for long, until you get to the point where you start having complex needs. So I think that's part of it. So let's see. So the nice thing with Pulumi, I think, is that you can just start with YAMLs and slowly transition. I know that they're getting better at that. I know I've talked to Joe and the team over there, and they are thinking about that journey from starting with YAML. But there still is a certain amount of, at least last I looked at it, where you have to pick a programming language. You have to sort of create some scaffolding around it that may be intimidating. All right. So let's see. So I have KBLD. I got to do these things one at a time. KApp. Downloading. So I had a little bit of a scramble before we started TGIK because I went ahead and I actually have my laptop hardwired into the network here. And they actually locked that down, so I wasn't able to do YouTube streaming, and so I had to join our guest network here to do this. And so I'm not actually on a hardwired network here right now. So hopefully we don't hit any hiccups and things are going to be going to be fast enough. Okay, so we got the tool set now. We can type YTT, we can type Kapp, that type of stuff. I have a collector kube control, get nodes with just a couple of nodes, and we're off to the races. Okay, so let's actually start going through and actually explore what this looks like. And I think the right place to do this, Abdenor says, coming late, but quick question, does K14S equals K8S plus K? No, K14S stands for Kubernetes tools. So that's the K and the S, and I guess there's 14, I didn't count them, I guess there's 14 letters in between. Does it count the space? I don't know, we can actually see. Kubernetes tools, I'm going to count here. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So yes, it does count the space. Otherwise it'd be K13S, and that'd be unlucky. Okay, so all right, so okay, so I think the right place to start here is to actually start with Kapp, and this is the command line that we're going to be asked to run here, and I'm just going to go ahead and run this, and then we'll explore what's actually going on here. So the nice thing, and you can already see that this is actually nicer than kube control apply, is that it actually tells me what's about to happen, which is really cool. It's like, hey, I'm going to create a deployment in a service. These are in the same namespace. I assume that the tilde here means that it's actually the same as the one above it. And these are going to be added. And so, you know, added, deleted, whatever, it's like it actually figures that out, which I think is super, super, super cool. So this is already much better than kube control apply. And then I can go through and I say yes, and it starts doing some output logging. And one of the things that you're going to see here is that it actually tries to wait until the things are converged and done. This is problematic. I mean, I think, you know, my guess, and I bet you if we cracked open the source code for Kapp, we would actually find that there's special casing for, like, okay, when you're doing a deployment, that means that you have to wait until, you know, you have the right number of pods, that type of thing. They probably have to have a lot of special casing for this particular Kubernetes resource. This is what it means for it to actually be converged, and I'm going to wait until that happens. That kind of sucks. And so this actually then brings us back to some of the patterns that the Knative folks were doing, whereas it would be great if we actually had a standard set of conditions where completed or ready was a standard condition, and then there wouldn't have to be special case code in tooling like this. And so this is actually, I think, a bug/missed opportunity in the Kubernetes schemas to be able to do this. And you know, maybe we'll go ahead and fix this at some point, but it's one of those, like, it's going to be a lot of work, but it would be very cool if we could do it. So Dimitri says, currently we special case a few things, but want to add some generic rules that authors can add themselves as annotations. And yeah, definitely would be great. Yeah, maybe this would be something that, like, it becomes part of the schema, because I think one of the other things that I look for in a tool set like this is really understanding the working with CRDs and the extensibility for Kubernetes. I mean, Kubernetes is an extensible system, and that extensibility is becoming more central to what Kubernetes is. And so we definitely need a tool set that recognizes and works with and takes advantage of that extensibility. So yeah, so this would be super, super cool to see more patterns, more schemas that actually make this stuff work more automatically. All right, so that was super, super easy. Now, when we go and we look at this, we did a kapp deploy, and then we had this A, which was simple app, and then -f was the config step 1 minimal, which is the pointer to the YAML. That's the file name directory that we're pointing at. So the question is, what is this sort of simple app -a? So I can do help. Does this work? Look at that, that works. All right, so I'm going to look at this, and this is the app string. Set up an app name or a label selector here for deploying this stuff. And so what we have here is that if we do a kube control get deployment, How do I, oh, can I show like, there's like show me label columns. Can I show like all the labels? I don't think. All right, we'll just do YAML. So when we look at this, one of the things that we're going to see here is that as this got applied, so first of all, there's KApp original. This is actually similar but different to the way that kubectl apply does. It's kind of interesting to see that these things aren't quite exactly the same. There might be, you might want to like try and actually fix these at some point. There's things like diffs and stuff like that to actually be able to do the three-way merge. And then we actually have like labels here where there's a unique app thing and an association. I don't understand what all this stuff is. I'd love to explore it. I'm guessing that this is like some sort of hash based on the app name or something like that. And then that identity actually gets put into here around the simple app. Oh, okay, so just a timestamp with nanos. Okay, so it says the bottom of the screen is actually cut off. How's that? Is that better? Show labels. Okay, so yeah, so I can do, I need to, there we go. All right, so yeah, so now we have that. So you said that that's just a timestamp with nanos. Kapp.ls, okay. We can do that. Okay, and here we have the actual label here. So one of the things I'm wondering is how do we actually, like, does this timestamp get written out anywhere? Do we actually know, how do we actually, if I do another apply, how does it associate it with that timestamp? Like if I do like a Kapp deploy simple app to, what does it actually do? Okay, so here we go. Well, deployment simple app is associated with it. Okay, so there's at least, this becomes protection so that you actually don't accidentally apply two resources with the same name into the same namespace, but from different apps. So that's actually pretty cool. So yeah, so there's, and the other interesting thing here that comes into this is that there is this experimental feature in kubectl apply called prune, which actually says, if I see resources that are in the cluster but not in my YAML, how do I go through and actually make sure I can delete those things? And that's actually a hard problem. It's like, you know, a lot of times we call this tombstoning. How do I actually know when I'm doing a diff that I should delete something versus just add or change it? And so having identifiers for the app like this becomes a critical piece of that puzzle. And so if I go through and let's say I go back to our YAML here, and I'm already going off script. So Dimitri, this is what I do, I'm sorry. And we're gonna actually go ahead and delete the service that we have here. And I'm gonna save this. And now if I actually do a deploy again, same command I ran before, what we're actually gonna see is that, oh, the change that we have here is that we're seeing a delete. How did Kapp know to do that, right? Because Kapp knew that I want to do an apply. Now the apply that I'm doing is just a deployment. There's a service in the cluster. Now, like, Kapp is kind of stateless here. It doesn't know, at least on this side, it's stateless. It doesn't know anything about the service at this point. How does it know that it actually should go through and delete the service? And it does that by listing all the things and looking at the labels and the metadata that it's keeping, so that it can actually say, oh, okay, I know last time I did this, I used to have a service. Now I don't have a service. I have to go ahead and delete it. So that's a piece of the flow here that is missing with kubectl apply that is here with Kapp, which is much more amenable to sort of like a real GitOps flow where you actually both add and delete stuff. Okay, so Dimitri says that there's app to label connectivity in the config map. Okay, so yeah, so there is no storage locally, but that metadata then gets stored into a config map. So I'm not going to actually do this. I'm going to undo this. I'm going to do this. I'm going to do kubectl get config map. All right, and here we actually see kubectl get. What did I do? Okay, get config map. And here what we see is the config map is actually Okay, so we say like here's the label key and the value, and this actually gets mapped to, yeah, so this is all a bunch of metadata for, so that is actually, looks like it's maybe history of the thing. And then we have change. And this is like, okay, and then so this is essentially the log. So what Kapp does is then use config maps as actually a data store to keep track of this stuff, which is actually pretty cool. Shahar says, if I applied a resource with kube control and then started using Kapp, would Kapp know about the resource using labels that Kapp creates? I think, and Dimitri, if you can tell me if I'm wrong, I think Kapp only can manage stuff that it was used to apply the first time. I don't know if there's any way to sort of adopt resources into Kapp. That would be interesting. And so there's a lot here. I don't necessarily get all of this, what's going on, but it's definitely some interesting stuff. Dimitri says it would adopt it. Okay, so it doesn't have a conflicting Kapp app label. Okay, okay. So this is like if I do kube control apply -f of if I do this, what you're going to actually see here is that kube control apply has the same thing. It's going to give me a warning saying like, now it didn't actually ask me if I wanted to do it, but it's going to say kube control apply should be used on resources created by either kube control create with save config or kube control apply. And so save config in create actually does the same thing. It actually writes a bunch of metadata so that we can track this deployment as a unit. Okay, so now what happens if I actually reapply with Kapp? Okay, it's going to actually go ahead and fix up the metadata on these things. Boom. All right. So yeah, cool. All right, so that I think that would look like if like, because when I did the apply, I probably whacked the metadata, and then when I did the Kapp deploy, it essentially recreated and re-added the metadata onto this stuff. All right, so other interesting things that I want to actually explore. All right, so so this is fascinating. So you can actually go through and start restricting what Kapp can do. So you can say, hey, I only want to like make sure that I apply to these particular set of namespaces, or I want to go through and let's see, there were some other stuff. You can do certain types of filters where it's like I want to apply some types of things but not other types of things. So you can filter on sort of the kinds. And then you can filter on name, on namespaces, and then you can map resources from one namespace to another. And so I think, and I haven't actually tried all these things out, you can use this to essentially say, you know, okay, I want you to do your regular apply, but I want to actually put some guardrails on you. And so this works well if you just want to have, let's say that you're doing like a GitOps flow. And you have a structure such that you have one repo, and every directory under that repo maps to a namespace, right? And then under that directory, you have some YAML, right? With kube control apply, somebody in like namespace foo could go ahead and put YAML in there that writes random stuff into namespace bar, right? And so that means then that you have to, you know, there's no way to actually sort of cordon this stuff off when you're doing something like a GitOps flow. With something like Kapp, what you could do is you could have your apply saying like, oh, when I'm in directory foo applying the YAML for namespace foo, I'm going to actually configure Kapp so that it actually doesn't allow that thing to touch anything outside of namespace foo, right? So that's a really, I think that's a place where you might use some of these types of capabilities. Another thing that's really interesting, like I said, every time I download something off the internet and try and install it, I want to go through and really examine what it's doing and what types of resources it's going to be creating in my cluster. If you remember, like, I don't know how many of you were there when I actually did a review of CNAB. So I think there's a lot of great ideas in CNAB. The idea of being able to take an application, package it up into a single artifact that you can ship around is awesome. The thing I absolutely don't like about CNAB is that it's self-executable. The way you install a CNAB application is essentially take one of the containers that's in that bundle and run it. And then you hand it your Kubernetes credentials and have it run. And so that means that the thing that's deploying your application is the same thing. So the thing that's deploying your application is sort of comes from the same place where the application comes from. It's a self-installing executable, or if I want to be really mean, I say it's like ActiveX for Kubernetes. I think what I like about Kapp, and with maybe a more limited form of CNAB, is that we could have a standard place in a CNAB bundle for where your YAML is. You could use Kapp to deploy it. It could extract that thing, and then independently help you verify what's in that YAML before you go ahead and apply it. And so I think having your installation tool chain be different and separate, or your packaging tool chain from the thing that's actually being deployed, is a really important sort of sanity and security mechanism. And so I really like to see that Kapp's moving in the direction of actually moving some of that verification, some of those guardrails into the deployment mechanism. So Dimitri says, and this is very true, there's a caveat here, it can't verify what the deployed containers can do. So like, he's saying it doesn't sort of like start to sort of trace through which service accounts and what RBAC is and all that. So you're still going to want to dig a little bit deeper if you're actually installing cluster-wide RBAC rules. But I think, there's room for sort of further static analysis of the YAML before you apply it. And I think that'd be a really interesting direction to take this type of tool chain. All right, so so I'm totally off script. Let's see, so Bill's saying, maybe I'm a little off topic. Yes, very off topic, but that's okay. But please, is there any solution to do a DNS-aware network proxy? Calico is only L3. Bill, that is a really interesting question. Having a more flexible networking in Kubernetes is a very hot topic. There's a very early project that I want to do a TGIK on sometime soon. It's a sandbox project in the CNCF called Network Service Mesh. And so it's essentially a way to use Kubernetes config to create sort of virtual Ethernet wires between different pods. And so it adds new interfaces that can do that. And then in that way, you can configure, and I think one of the things that they're looking at as part of that project is there a way to actually start joining and sort of doing overlay DNS as you start creating smarter and better proxies. And so one of the goals that they want to do is like, hey, I want to run a pod in my cluster, but I want to give this pod VPN access back to my corp network or whatever, but just that pod. And so there's scenarios where you can actually run that pod as normal, set up a connection using network service mesh to some sort of VPN thing, and then have that thing actually talk the VPN protocol to the ultimate VPN endpoint. Totally off topic, fascinating problem, really interesting project that you should take a look at. Still very early though. Okay, so let's see here. Okay, so we're off topic. So we did Kapp LS. Oh, we have an inspect here. This is cool. All right, so this is really, really interesting because we essentially have we created two objects, the service and the deployment, but in turn, those things actually created a bunch of other objects. And so it looks like Kapp actually scrapes up enough data out of Kubernetes, maybe using some of the owner refs, to be able to construct this tree of which resources are parented to which other resources. That's actually pretty cool. That's a really neat visualization there. And then, let's see where we at. And then we can do logs. Oh, this is actually really cool. And so, okay, so so all we got is a server started log, okay. But we're not actually hitting the thing yet. So what we were doing, okay, so we deployed the application. And so we can do a port forward here. I'm gonna go ahead and do this. because this is good times. Localhost 8080. Okay. Well, look at that. I have. Okay, it says hello, stranger. Okay, so we have that, and now if I do the logs, we can actually see the request received there. So I assume that this is doing like -f is a follow, sort of a live tail. I'll do that in the background. Start the port forward. Oh wait, did I? Oh, I just stopped the port forward, so I'll just do a foreground on that. And then I can do this, and yeah, so if I refresh, we're getting a bunch of requests. Okay, so that's a pretty common development flow. The port forward, logging, all of that stuff. I think this is interesting because this starts to overlap with things like, oh God, what was the Google project that essentially does the rebuild, redeploy stuff? Part of your development workflow ends up being like, I want to see logs in the thing, I want to be able to redeploy. This doesn't do the redeploy, but it does sort of the logs and the port forward, and that starts to get into the KWT thing, which is essentially a workstation tooling altogether. Scaffold, yeah, thanks, scaffold. So I think, this is what's so fascinating about the Kubernetes ecosystem is that we still don't even know where the lines are between these tools, right? We create new tools, they overlap with other tools. There are very few places in this world, and I think this is one of the things that makes it intimidating for new users, but there's very few places where System A and System B are truly apples to apples, right? There's always like, well, this thing does a little bit of that and a little bit of that and a little bit of the other thing. I think that's a sign that there's a lot of really great innovation going on. But I think it also makes this stuff be incredibly intimidating because the battle lines in terms of where the products are, where the projects are, how they relate to each other are still very, very, very fluid. So I'm not going to do, okay, I'll do this thing here. So how does this work? So this is actually going through, it's doing cluster.local, it gets mapped in. Does it actually start a DNS service and actually rewrite this is what makes me scared about this, is that does it actually go through and rewrite my Etsy hosts and my resolve? Does it? Okay, I want to look into this at some point in the future. Yeah, so this is different. This is similar in some ways to telepresence, port forward, proxy. Don't use proxy, but yeah. Okay, so it sets up packet filter rules. Doesn't change config files. Okay, that's cool. Does that work on the Mac? I wonder. Okay, well, we'll explore that another time. So that does work on the Mac. Okay. All right, so now we're going to change this. We have an environment. Hello, TGIK. So we're going to go ahead and do that. So this, okay, so if I did hello, no. And then like, so this is the YAML thing, right? So now I actually go through and I do deploy. Let's see what's going to happen. Yeah, okay. And then what happened here is that the server barfed on this. So I think it might be interesting, again, more validation. I don't know if this belongs in YTT or Kapp. But like, there are tools out there that help you do sort of pre-flighting and, of this stuff so that you can actually go through and see, do schema validation. And there's dry run stuff being added to Kubernetes that might help here also. So that's actually pretty cool. Okay, so but we're going to do value TGIK. We're going to do the mod. I say yes. So you'll notice that it's waiting for the deployment to actually roll the thing. And now I come back here and I'm no longer running my proxy. Oh, and then the logs are actually still running in the background. So let's see if this works. So port forward. Okay. Wait, no. Cube control, not that one. There we go. Port forward service. So now that thing's running. Okay, and this is really cool. So this is something that's nice, is that the Kapp logs actually continues to spew logs even after things restart. A lot of the stuff in kube control, it works great, and then something changes in the cluster and it breaks. So that actually kind of sucks. All right, and so apparently, so let's TGIK. I'm going to go through and let's do this. So I'll change it again, and Dimitri is saying that there's a -C that actually shows changes. All right, so here you can see that we're actually digging a little bit deeper here, and we can see the changes. And yeah, super cool stuff. And I start seeing this, I'm thinking about how can we put this into other tool chains? How can we actually make it be more visual? How does this apply to GitOps? Lots of exciting stuff that can happen with a decomposed tool chain like this. All right, so here we can do like diff changes. Since the service was changed, nobody ever talked about it. And then one of the other interesting things here is that, the YAML that's getting pushed in doesn't have to come from disk, and it can actually come from anywhere. One of the tricky sort of gotchas here, if we look at this command line here, can you all see this? Is that here we're doing Helm template, which is a great way to sort of use templates client side before we get Helm 3. And Helm template generates a boatload of YAML, and then you can do Kapp deploy, and you don't have to write this stuff to disk. But what you're saying here is the -f-, anytime in a Unix command where you specify dash as a file name, it generally means read from standard in instead. But the problem is that if we're reading something from standard in, there's no way to actually get that keystroke that says yes or no based on the diff, right? Because we only have one standard in, and that standard in is being used for the YAML, it's not being used for the keystroke. And so if you use the -f-, it has to be paired with yes here. And the yes says, skip the diff, show me the confirmation right off the bat. So last time I tried this, if you didn't specify the yes, it would error out in a weird way. And so I think having, from a user experience, Dimitri, just if you forget the -yes, just saying something like, hey, piping into standard in is not compatible with the default dash, rewrite it and do this, because otherwise you get a bunch of spew and you're like, what the hell went wrong? At least that's what I got. All right, so that's Kapp, which I think is really cool. Now I want to start looking at the other tool, which is YTT, which is a templating tool. Okay, so there is a to-do to improve this. You're way ahead of me. So YTT is a templating tool, so we can actually go through and let's pull up VS Code, and here we have template, and we have config and values. Now, when we start looking at a template here, you can see that there's this special thing here where it's #@, which is essentially saying this is a command to YTT to be able to do stuff. And so there's a dialect here that says load this stuff, and then we have def and end, and then this is how you actually do a substitution. So you might do foo if you were using Helm, right? But here you actually do this particular thing. Now the interesting thing to keep in mind is that this is structure aware, right? So if you're authoring Helm charts, you gotta you do Helm template and you say, oh, my indent is slightly wrong, and so there's all these helpers to make sure you get the indent right. You don't have to screw with any of that stuff with YTT because it knows sort of the context of how you're joining stuff. And so if I have labels here where I have simple app equals foo, and I have can I actually put, I think I can do this, bar baz, then that gets put down into the selector here and into the labels, because a lot of times Kubernetes YAML is so verbose where most of the time, 99% of the time, you're actually repeating labels again and again. There are scenarios where you don't want to actually have the exact same labels, which is why we did it. But if I go ahead and do that, you can see I have a couple of things here. I'm not mucking with indenting anywhere here. And so that's the sort of recognizes the structure aspect of YTT. That's really cool. Now, astute readers will look at this and say, def and colons, this looks a little bit like Python. And it is kind of a dialect of Python. So we're going to go a little deep here. YTT uses this thing called Starlark, which was actually part of Bazel, which is the build system, or at least the open source version of the build system that Google uses. And so in the Google monorepo, every directory has a build file. Inside the build file is essentially like a little mini Python program that generates like, here's all the targets of the things that I want to build. And as they took this into open source, they got a little bit more formal about that dialect of Python that they're using. They gave it a name, Skylark, but Skylark was already used for something, so they renamed it to Starlark. You'd think they could have done like a Google search before they open sourced it, but whatevs. And so Starlark ends up being a contained dialect of Python. Not only that, and I think this is super cool, is that there are multiple implementations of Starlark. And so you can embed it directly in Go. And it's a simple enough language that this isn't a crazy thing to do. I think it would have been interesting if Helm 3 had actually chosen to do something like Starlark instead of Lua. But we are where we are at. And so what happens here is that as we look at this, you're essentially writing sort of like Python intermingled with YAML, but in a structural aware thing, which I think is really cool. One difference is that you do have to be specifics about ends. It's YAML is whitespace aware and Python is whitespace aware, and so these are not two great tastes that taste great together. So it sort of modifies the Python-esque thing to actually not be whitespace dependent, which is kind of neat. One of the things that I noticed, and we'll get into this, is that it doesn't support or at least last I tried, it doesn't support non-code labels, and like you can't actually do true comments. And so this is one of the things that, like, if you just take plain old YAML and pipe it through YTT, I hit an error the first time I did this. But let's continue on with the blog post here. And so now what we're doing is, if we look at this, we've gone through, and hello message is now actually coming from this data.values. That data is actually being loaded from a sepal file called values here, where now I have the app port, the service port, and the hello message. Okay, now Nima says that that Nima's one of the other authors on the project here, says that the ability to have regular old YAML comments is fixed in the latest version, which is exciting, because like that definitely tripped me up and confused me when I hit it. So yeah, I think the goal of being able to take regular old YAML, pipe it through YTT, get something that's semantically equivalent on the other end is sort of probably going to be the starting point for a lot of folks. So when we look at this values, this looks a lot like, if you're using Helm, like the input for Helm, which I think is really cool. So we have this simple sort of like, we've pulled out some values, we're actually going through and grabbing this stuff, and then we're off to the races. One of the things that I don't think you can do, and like, Neiman Dimitri can correct me if I'm wrong, I don't think that you can actually in here actually reference other parts of the structure that you're dealing with right now. So I can't do I don't think you can do this. And that's probably okay, because I think it's a templating language. This is the type of thing that you can do in something like JSONit, where you can essentially reference other parts of the object that you're modifying as you're modifying it. This was a very common pattern in Borg config inside of Google, which turned into GCL. But this is okay, because now I think what this means is that you have to be much more explicit. pull it out like the labels here versus being able to sort of create spaghetti by referencing random stuff and random things. Yeah, ordering, it adds a lot of complexity to something like JSON to be able to do that, because you move from being sort of a procedural type of thing, and this is what Dimitri says when he talks about ordering, to something that's purely functional, where in functional languages, you write it in order, but the evaluation is totally out of order. It's a logical evaluation. Okay, so let's actually see how this works. So we got that. Now we can actually go through and we can go through and we can do YTT template and then -F, and then we can give a -V, which is a way to essentially modify. Well, let's take off the -V to begin with. If I do this, this essentially goes through and runs the evaluation, outputs YAML, the ports and the labels and everything actually get passed through. And so if I go through up here and I go and I do, you know, foo bar, I can go through and now actually you can see my labels have foo bar in my selector. So we actually, that's sort of how structure works. And nowhere in here did I actually start mucking with indent levels for YAML. But a lot of times you actually want to be able to, you know, modify this in a very sort of lightweight way, and that's where the, let's see, that's where you can do the -V here to be able to do this stuff. And so now if I do this, we can say now the value got changed to K14S user. And so, and we can go through and we can pipe this to Kapp. Now I'm going to leave off the yes, so you can see the sort of the thing that I was talking about before. When I do this, like it does a bunch of stuff, and then it says asking for error, asking for confirmation EOF, right? I know what that means is that like after YTT wrote out the YAML, it actually closed standard in, and then when we got to this, Kapp started trying to read from standard in, but was closed, so it got an EOF signal. That's what this means here. Not a great error though. So if you see something like this as you're doing these things, that means that you're not allowed to actually do an explicit confirmation. You have to go through and actually just say yes, go ahead and do this. And so now we're going through and we've applied it and we're off to the races, and we can see that our logging is still running in the background. And this got, you know, this got recognized as the same app because it was called Simple App. And so this is sort of simulates the flow. If I start with plain old YAML, I'm not even using YTT. I now slip YTT into my tool chain. I can continue to deploy just like I was before. So that's pretty cool. And then the other interesting thing here is that, oh man, config theory, right? There's like should be a PhD course in this. There's these sort of two different schools of thought. There's the patching school of thought, and then there's the templating school of thought. And Kustomize is all about patching. Kustomize prides itself on not actually doing any templating, but they actually do. There's a couple places where they have some values. They're starting to blur the lines and do a little bit of templating. Something like you know, KSonnet, when we were actively working on that, or Helm, is all about templating. And the good thing about templating is that it's easy to author, it's easy to wrap your head around. The bad thing about templating is that as you start configuring more and more complicated things, like say, look at the Helm chart for Nginx, the number of parameters going in actually starts to balloon. And it balloons because the only way to modify it is by adding a new parameter. And so every possible change that any possible user might want to that thing ends up being another parameter coming in. Now you can have good defaults and all that so that the user experience is relatively streamlined, but the authoring experience for something like a Helm chart, you know, in the fullness of time, gets pretty awful because everything is a parameter, and everything but everything ends up becoming a template. And so when you look at a mature Helm chart, it's nothing but template substitutions. And so that's kind of a crappy situation. And so I think the thinking behind patching is that we can make modifying it harder, but we can make authoring it simple. And so patching is a way to apply arbitrary changes to the underlying YAML. It's more difficult than actually sort of filling in the blanks in a parameter, but it's also much more flexible, and it makes the sort of the mainstream mainline authoring of the thing that much easier to actually happen. And so it looks like Kapp also supports a patching type of mechanism. And so that's where we have overlays here. And so here, essentially what this is saying is I want to do load overlay. Okay, so I'm trying to see here. YTT overlay. So this is a library that we're loading. And then I'm saying I'm doing a match for the deployment, and I want to actually go through and set replicas into this thing. And so this is essentially the diff that I'm going ahead and doing. And there's annotation of like, well, if it's not already there, that's okay. Now, one of the things that I'm wondering is, does this understand the different merge strategies and merge keys and stuff like that? Because one of the things that we did in Kubernetes, for good or ill, is that we'll have a list, and then we'll have a key member of that list. You can think of it as kind of a primary key in a database. So, and we say, okay, this is the thing that identifies the row that I'm talking about, and that's called a merge key. And that's schema specific to the type of thing that you're talking about. We could have gone through and actually said, okay, we want that merge key, instead of actually making a list, make it a map, hoist the merge key out from actually being that thing into actually being the key to the map. But that creates its own challenges because a critical piece of information may not actually be in the subtype. And when users read the YAML, they look at that key and they're like, is this something I can change, or is this something that's intrinsic to the system? And so that ends up being a little bit tricky about that. So Dimitri actually has there's a document that starts talking about overlays, and I'm sure you all have bumped your head on this and have started thinking deeply about this. So let's go ahead and see if we can actually see that. Do YTT. Let's see, docs. It's pretty thin right now, but language, so this is docs. Language ref, YTT overlays. Okay, so we can do apply left and right, sort of merges these things in. Yeah, and so what happens here is that when you do this, you have to specify the map key. Tools like kubectl apply, or actually tools like kustomize, actually are Kubernetes schema aware enough that they actually know how to know, they can read the map key out of the Kubernetes schema. And so that ends up being something that's a little bit trickier to wrap your head around with YTT. Okay. Okay, so now what we can do is, so let's look at this command line here. So oh, this is fascinating. I love it. Okay, so what we're doing is that we're actually going through, oh, actually, yes. Okay, so we're going through and we're evaluating the template thing, and it's doing Kubernetes user. And then we're doing another deploy, and we're piping that as an input, and we're doing, no, that's not the right thing. I copied the wrong thing. No. Template. Ah, okay. Did I do that? Did I do the right thing? Oh, actually, I see what we're doing. We're specifying both the template and the base. Okay, so the template is the base, and then we're specifying the overlay as another file, and then those things actually get merged together. This is slightly different from kustomize, because kustomize actually has a, in the base YAML sort of that specifies the application, it actually has a base member that says, well, here's the base customized configuration that I'm talking about there. Whereas here you have to know what the base is as you're actually doing this on the command line. One of the other interesting choices with YTT is that it doesn't have an opinion about your layout on disk. I think one of the things we did with KSonnet, I think one of the things that Kustomize does is that there's this idea that if you lay things out on disk in a specific way, it has implications in terms of the relationships between different files. This is in some ways inspired by things like Rails, Ruby on Rails, right? Where there's a sort of don't repeat yourself dry type of thing. And one of the ways you get away from that is having opinions about how you lay things down on disk. And so Nima says that you can also drop the overlay into the base and it'll pick that up. But then they're in the same directory, and so you don't get that separations of concerns. Now, I don't think this is a bug or a problem with YTT. I think what this may be is an opportunity to actually create another tool on top of this that essentially runs YTT in an opinionated manner, maybe drawing some values from a separate config file and actually implying and understanding things based on how things are actually laid out on disk. So I think that's another example of maybe a separation of concerns where there's different ways to actually do this. So I could see there being some sort of K14s Uber tool that knows how to say, well, if you have things laid out on disk this way, we'll run YTT, we'll be able to display the diffs and actually let you confirm because we'll write it to a temporary file before we pipe it in. All sorts of interesting stuff that can be done over time there. Yeah. Okay. I'm going to do some bash tricks here, like bash write to temporary file. I forget the bash syntax for this. There's like a thing that says like run this command, save it to a temporary file, and then put the thing into the command line. And is it like, oh God, I'm gonna be like, all right, I'm totally going down a tangent here. All right, I'm going to do that later, but I think there might be a better pattern where you can both get the confirmation and not. Okay, so we can go ahead and do this, and then we'll go ahead and apply it again, and we're going to see the changes. There were no changes. What did I do? I think I copied the wrong thing. Oh, not that. There we go. All right, and here you can see now we have 3 replicas of this thing, and when this is done, so now let's do the port forward. Port forward, that's up and running. So hello K14s user. Oh, it looks like it's always hitting the same pod. I wonder what's going on here. Kube control get pods. I think there's just stickiness in the. Oh, that's right. So port forward. Okay, I remember. This is something less than optimal. So what port forward does, it doesn't actually forward to the service. It actually, yeah, I wanted to fix this in kube control port forward. It uses the service as a selector to pick one of the pods and just forwards to that. That kind of sucks. Yeah, so help wanted if somebody wants to write a better port forward or a tool or that would actually be kind of cool. Okay, so but we do have 3 pods there running now, so there we go. Okay, so let's see, and I think let's see, and then we can talk about how do we build this thing locally. So this is interesting. So there's kbuild. I'm not going to actually do this, but so kbuild, what it does is it actually goes through and it container image building of the deployment workflow. So it looks for images within the application configuration, so image keys. So this would be a place where the duck typing that the Knative folks are doing would be really interesting. Because then you wouldn't have to hard code this. Checks if there is an associated source code. If so, builds these images via Docker. And finally, capture building digest. Okay, but the one thing it doesn't do is do a Docker push. I'm operating on a remote cluster, and so you have to do things like, use the Minikube Docker eval so that it works with a local a local type of thing. but it's not going to actually work with when you're doing development to a remote cluster. But I think there's like, could be pluggable with other builders. So I think, yeah, making this pluggable with other builders, doing cloud builds, actually making sure that you're doing a push, picking unique names as you do a push. I think that would all be interesting ways to actually sort of modify this and actually make this more interesting. But now you can see how this tool set starts to really overlap with things like Scaffold. So Dimitri says, what are your thoughts about shipping configuration as libraries? One example would be, K14s Kate's lib. Oh, it does a push if the registry is specified. Okay, so it does do a push. So Dimitri, what are you thinking about with a library? Essentially a bunch of sort of Python helpers for this stuff. I think that's really interesting. My advice based on, oh, there's a repo in there. So do we actually have, so we have like YTT, is it, oh, K14s Kate's, lib, okay. NSA comments, what is NSA? Okay, so, all right, so this is, I think, I'm torn here because this starts to, I think, hit some of the issues that we hit with KSonnet. Whereas I look at this and coming from somebody who knows Kubernetes YAML, I don't see the connection between this and the Kubernetes YAML that I already knew. And there's a lot of voodoo going on here. And so, one of the things that I think is interesting is when we look at the config space. I'm going to draw something. I don't have my document camera set up here. Is that I think that there's a sort of foursquare type of thing where we have has YAML. Or actually, I'm drawing on a post-it. I'm going to hold it up the camera. We're going to be totally. Actually, I can't do it. I have an iPad. I want to get it to the point where I can actually do stuff here. Okay, but I think it's one of these things where here's the analysis that I did on this stuff. No YAML, and then like has YAML, and or sort of simple complex is on one thing, and then we're like new user, experience user. And so, I'm looking at a sort of an analysis like this. And when I think about this, if we have like, somebody who doesn't know YAML and they don't have anything already, like new users that haven't experienced Kubernetes YAML yet actually don't exist, because most people, when they come to Kubernetes, they start with the YAML. That's where all the tutorials are. And so I think we need to create, and this isn't exactly the thing, maybe I'll write a blog post on it. We have to create a smooth path for them into this. And so I look at something like this here, and this is just an enormous leap from I understand Kubernetes YAML to this, right? In some ways, this feels like it's the similar type of leap of I understand Kubernetes YAML to like Pulumi, right? Where, this, I'm sure there's a lot of power here, but there's also like a whole new thing I got to learn before I can even wrap my head around what's going on here. So that would be my only concern here with this stuff. I know there's a whiteboard behind me, I can do that, but actually I set up my camera to have manual focus, so if I actually start writing on the whiteboard, I don't think y'all are going to be able to read it. I thought about that. So let's see, so this does auto build, which is pretty cool, and so I think, oh, and here we go, here it's pushing to the registry. So here's build local, pushing to the registry, build and push, and then push image is true, push images repo. Okay, I'm just going to look at the, because I don't think we have enough time to really set everything up. but we have build config values. So we have a bunch of stuff here. So we're loading data in assert. So we have. Okay, so there's a new CRD here, CRD-ish thing that ends up being input into. Okay, this is really interesting. I like this. Metadata that actually starts telling the tool chain what to do is actually embedded as objects, but gets stripped out before they actually go ahead and get applied. That's a really interesting idea. And so this says that, we have a source here, and I think, is that part of the build also? Yeah, so we have a build here. So this actually sort of follows the Kubernetes mechanisms, but it actually runs locally as part of the tool chain and gets stripped out before it gets applied to the cluster. So we have this here, and then here's the image where we're actually using it. And then push, we have, okay, and here you can actually have, there's a new type of thing which is called image destinations. And we have things like asserts that actually say, hey, you must actually specify this. So that's actually, I like that. That's really cool. And I'm wondering if you can actually template this stuff also, whether this image name actually could be one of the values that I actually pull through. Pretty cool. Okay. So I'm pretty much out of time here, but hopefully, and I'm out of time and I'm out of blog post. But hopefully, this gives folks an interesting idea of sort of like, the ecosystem and the sort of power around taking this problem, breaking it down into some component pieces, and then building back up based on that. Really, really interesting stuff. Something I'm really excited to see where it goes from here. I really like that this is super compatible with sort of the GitOps workflow, more so than a lot of other tooling that's out there. It's going to be interesting to see if, what does this look like in conjunction with things like WeFlux. Flux is actually just applied to become a CNCF sandbox project, and so that's probably going to be happening sometime soon. But I think seeing this decomposed tool chain for me is super, super exciting. So thank you, Dimitri. Thank you, Nima, for joining and for building the tool and sharing it with us. Really exciting stuff. And I'm probably going to be doing more TGIKs here for a while. We're going to probably have Duffy and Josh pick some of that up. We're trying to find some other folks to step in. I know we have a non-Heptio alum who's really super interested in doing this. This is Christian Dickman, who's been at VMware forever, doing a bunch of storage stuff, getting involved in Kubernetes. Really excited to start showing stuff off. Also, I'm trying to convince Olive Power, who's one of our field engineers in London. She's expressed some interest in doing it. I'd love to see her do that. Maybe we change up the time so it's something more local for her. Be a little bit fair to the rest of the world. That might be kind of fun. So thank you everybody for joining me and sticking with me through all this. I think it's been a blast, and I learned a lot every time I play with these things. It expands the way I approach this stuff. So very, very, very cool. And I will see you all next week.